In the previous video of synthetic division, we have seen how to perform synthetic division. In this video, we will do few more examples of synthetic division. If we have to divide a function f of x is 3x to the power 4 plus 4x cube plus 3x minus 2. If the function fx has to be divided by, say, function qx, which is x plus 2, by synthetic division, let us see how we do it. So a very important thing here, we know that in synthetic division we have to write the coefficients of the terms of fx. So when we write the coefficient, we write 3, 4, 3 and minus 2. And we try to divide it by, we have to negate the constant part in the divisor. So we try to do it by minus 2. This is how we do synthetic division, and this is a common mistake made by the student. If we are writing the coefficient 3, 4, 3 and minus 2 like this, and we try to perform synthetic division, the remainder which we get here will be wrong. A very important thing which we need to keep in mind while performing synthetic division is that arrange the dividend function in descending order of the powers of the variable. Let us see what we mean by this statement. We have to arrange the dividend function in descending order of the powers of the variable. So in our case, the function f of x is 3x to the power 4 plus 4x cube plus 3x and minus 2. So let us first arrange it in descending order. So the first term will be 3x to the power 4. The second term will be 4x cube. After the power 3 comes the power 2, but we have no term here which has a power of 2. So we will write 0 times x square. We will write an x square term with a coefficient 0, and then we write a 3x term and a minus 2. Doing this is very important, otherwise we get a wrong answer if we perform the synthetic division with only these 4 coefficients. Now, the second thing, as I have already mentioned earlier, to check in the divisor is that the coefficient of the leading coefficient or the coefficient of x should be 1 and the degree of the divisor function should be 1. In our case, both the conditions are satisfied. So let us go ahead and solve it. So let us write down the coefficients now. We'll write 3, 4 and then we will write a 0, which is the coefficient of the x square term, then 3 and then minus 2. If we try doing it 3, 4, 3 and minus 2, then I'm sorry, the remainder which we will get will be wrong. So let us go ahead and solve it. We have to take the constant part and negate it. So when we negate the constant part, we get a negative 2. Let us repeat again. Take down the first coefficient as it is. Multiply minus 2 to 3 to get a minus 6. And you have to perform the vertical addition. So we get a minus 2 here. Again minus 2 gets multiplied to minus 2 to give you a positive 4. Then 0 and 4 added gives you 4. 4 into negative 8 gives you 4 into negative 2 gives you a negative 8. When we add it, we get a negative 5. And negative 2 into negative 5 gives a positive 10. And when we perform the addition, we get an 8. We have to separate the last term, which is our remainder. So when we perform this division, we get 8 as the remainder. Okay, and these coefficients form the coefficients of the quotient function. So our quotient function is given by 3x cube minus 2x square plus 4x and negative 5. Please note that the degree of the quotient function, let me write it down here, the degree of quotient function will be 1 less than the dividend function. Because we are trying to divide it by a linear function. Is this clear? Because it is divided by a linear function. Okay. I hope this much is clear that the quotient function, we see here that the degree of the quotient function is 3 and the degree of our dividend function is 4. So the degree of the quotient is 1 less than the degree of the dividend because we are trying to divide it by a linear function. So this is all about synthetic division. If you have any doubts regarding this method, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel Mathacademy. If you have liked my videos, please don't forget to like, share and subscribe. Thank you.